It's been 50 years since SKYLAB launched into space. In the decades since, that space station and others have confirmed the usefulness of microgravity research and the benefits of long-term habitation in low Earth orbit. While sending astronauts to space stations seems commonplace now, the path to a continuous human presence in space began decades ago, as the Soviet Union and the United States designed initial space station concepts.
Subsequent mastering of space is inevitably connected with assembling complicated structures in orbit.
The Soviet Union's SALUT program successfully launched 7 space stations over its life, but faced many failures, including the tragic loss of 3 cosmonauts. SALUT laid the foundation for future station designs. One of the final modules, built in the 1980s, launched to the ISS and is still in operation today. SKYLAB was the United States' first operational space station. It was built using a repurposed third stage of a Saturn V rocket. 3 crews completed almost 300 experiments on SKYLAB, primarily focused on solar physics and the effect of microgravity on astronauts. The Mir space station was the first to incorporate modularity. It was composed of 7 modules launched individually and connected on orbit. Because of the modular expansion, Mir set a record for the largest spacecraft in orbit. The ISS later surpassed Mir in size. More than 100 cosmonauts and astronauts visited Mir during the 15 years it was in orbit. Today, the ISS provides research opportunities ranging from human health to dark matter. Studying muscle and bone mass loss in microgravity has led to innovative solutions that keep astronauts healthy while in space and has produced medicines that help humans on Earth. Other biological experiments include sequencing DNA and 3D printing human tissue. Because the ISS circles the Earth 16 times a day and travels over 90% of the world's population, it is incredibly beneficial for Earth observation. Astronauts have taken millions of photos from the station, and NASA provides these photographs to the International Disaster Charter to monitor catastrophes such as hurricanes and earthquakes. China's space station Tiangong is the only other active station orbiting Earth. The station began scientific operations in 2022 and has more than 1,000 scientific experiments scheduled. Today, the conversation is shifting to what will be possible on the next generation of space stations. As part of the Artemis program, the Gateway Outpost will be launched to lunar orbit to support humanity's return to the Moon. NASA does not plan to design or operate the replacement for the ISS once it is deorbited in 2031. It plans to be a customer of 1 or more commercial space stations. NASA has awarded $556 million to 4 companies for new space stations. Axiom Space will launch its first module to the ISS in 2025, while other space stations will launch between 2027 and 2029. These stations will bring new capabilities that could change how humanity views space research forever. To learn more about the new space stations, see the Q1 edition of the Space Report.